I'm Frawley with Ensource, Senior Network Engineer. We're in Jacksonville, Florida, in the lab today, and what I would like to illustrate and show you is Avaya data networking. 5.9's resilience, what they refer to as VENA, Virtual Enterprise Network Architecture. High availability, resilience, always active, always on. That technology comes from the evolution of the Nortel heritage actually being a carrier. They developed their network architecture around the idea that PDXs have to be up, 5.9s have to be up all the time. Well, why wouldn't your data network have to be that way? So they were kind of forward thinking in what they did, and they have had split MLT and RSMLT since 2001. This is not new technology to them. They can do it on their core 8000 switches. They can do it on their VSP 9000, the VSP 7000. They can even do it on the ERS 5000 series switches for small branch offices to give you the kind of resiliency that we're going to demonstrate today. Now, the beauty of this is they're able to have multiple chassis appear as one without the use of spanning tree. Any other time, this would cause a loop. They have the secret sauce that actually allows this to happen without implementing spanning tree. So let me summarize it. We've got simplicity, 5.9s, full redundancy, and management software that I'll show you today to be able to keep your customer up even with multiple failures in the network and never drop a call. So we're going to illustrate that to you today. As you can see here, this is our network that we run in Ensource right now. This lower part is the lab, this upper part is our production network. You can see that everything is dual hung back to the cores. What I've done is I've actually simplified this to a map that is just illustrating what we're going to be doing today. I have a phone off of this production core or production stack, and I have a phone off of this production stack tied back to the cores, the 8600s. So let's implement a call, which I'm calling this phone. Probably going to be feedback, so bear with me. Test 1, 2. We've got a call established. Everything is green. What I'm going to do is I'm going to take this switch, which is right here, and I'm going to, let me refresh that. I'm going to take this link down. I don't know if you can see that on the screen, but it's green. So what we've just simulated is you've had a GBIC failure, you've had a possible fiber cut, you've had somebody dinking around in your wiring closet and disconnected an uplink. Not good, right? Normally, with spanning tree, this would have to converge. It would initiate an algorithm. It would have to converge, take somewhere in the neighborhood of 3 seconds. Test 1, 2, 1, 2, 1, 2. We still got the call up. So you can see, go back to our illustration, do a refresh here. This is our map. And we should see that link alert. There it goes. Notice that we have a failure on switch stack 4, which is that one. You don't have to really zoom in on this, but it's port 24, 124, and it goes back to slot 4, port 48 on the core. So let's look at that, and you'll notice that on that core, that port is down. So it is not lying. So we have one down. Now what I'm going to do is, so we have one link. Notice that it didn't drop any packets. The call's still up. Test 1, 2. What we're going to do is we're going to take this link down over to the other switch. So now you've had 2 failures. You've had 2 fiber cuts. You've had 2 GBICs go bad, while the call and your customer, test 1, 2, 1, 2, test 1, 2, 1, 2, is still up and going. Sub-second failover, no spanning tree. So now that happened on this core switch. And you can see this is the one I unplugged. It's gone down. You can see that that link has gone down. And if we look at production 1, rack, refresh that, we can see that this link has gone down. So our uplinks, one of our uplinks on all of these are now down. The IST consists of, right now, 3 links on ports 1, 2, and 3 of each chassis. I'm going to undo 2 of those links. I have to leave at least 1, right? But we just had another failure. We just had another failure. We got failures all over the place. Test 1, 2, 1, 2. Test 1, 2, 1, 2, 1, 2, 1, 2. Call still up. Nothing's going down. Let's take a look. You'll notice that those 2 ports on the primary chassis are now down. These 2 ports on the primary chassis are now down. So we have 1, 2, 3, 4, 5, 6 ports totally down. Our network is telling us this. I don't know if you can see, these 2 are red and that one's blue. So we have down, 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 down. You had this many failures in your network. Check 1, 2, 1, 2, 1, 2, call still up. So, the problem with spanning tree is that not only does it converge when it fails, it also converges when it comes back in. So that means you fix the problem, you fix these Gbixes or this splice problem, and all of a sudden you put it back into service, it's going to take your customers down again. Not with Avaya. They don't use spanning tree. So what do? We're going to put all of these back in at the same time. Which means it will all converge at the same time. But what they do, what Avaya does, is they implement a little thing called VLACP, Virtual Link Aggregation Control Protocol. What that allows us to do is once that link comes hot again and becomes active, just because it goes hot does not mean it's passing data. You and I both know that. Ports always come up before they pass data. What does that cause? That causes drop packets because it thinks it's up and it starts forwarding data across that link. Understand, these links are active. What you buy, what you pay for, you use. None are sitting idle like in spanning tree. Spanning tree has one that's hot and one that's in standby. You're paying for something you're not even using unless something goes bad. That's insanity, right? You can tell our call's still up. Check 1, 2, 1, 2. Okay, so let's check and see. Yep, our network's fully back up. Everything's back up. All our switch ports, let me refresh this. All our switch ports are green. Our uplink ports are green. Refresh this. Our uplink ports are green. Our 2 servers, our 2 cores, everything is fine, hot, and dandy. Now what I'm going to demonstrate is something that really comes in handy. Say for example, right now, you have all kinds of resilience built into your core switches. You can have up to 3 power supplies, N+1, with this thing fully loaded with modules. 2 power supplies will run it. The third one is just for redundancy and N+1. You can have 2 CPUs. The 2 CPUs are in HA mode in these, which means they're high availability, so they're active. Remember, everything is active. There's nothing sitting idle. I don't know if you can see it, but there's a blinking light here telling me that this is the master CPU. This is the one that everything's been going off of. What we're going to do is, boom, you just lost your master CPU. Obviously, we didn't lose the call because it was screaming. That's 1, 2. But you just lost a master CPU. Now, say you wanted to do an upgrade in the middle of the day to the software on your switch. Not that I'm recommending that by any means. Always schedule downtime in case Murphy's Law happens, but say we wanted to do that to a chassis one at a time and you have to reboot it, right? Makes sense. Or you just had a power failure on the entire one side of a core switch. Test 1, 2, 1, 2, test 1, 2. You've lost nothing. Your customers are still up and running. We'll show this. This switch will completely go away as soon as the polling time times out. You will notice that these 3 links, which go over to the other core switch, are now down, illustrating that it's down. This eventually, it takes about a minute for that to refresh. You notice that just went gray, totally gray. That switch is gone. Totally gone. So, what you've done is you've either had a power outage. You can have these diversely fed off of individual power supplies, so that if you lose a circuit on this one's still going. You can have this in another room, in another location. As long as your cabling infrastructure will suffice, it's fine. You can do that. You notice that it's down now. All these alerts went up. It's going down. So, what does that mean? All this had to converge. Everything had to stop routing from one over to the other. Sub-second failover. Test 1, 2. We haven't dropped the call. I'm going to put this card back in. I am now going to power it back up. Here's the thing you got to remember. This switch, once it powers back up, and all that traffic that's being routed across this switch right now, when this comes back in, it has to automatically start an algorithm to pass that traffic across both of them again, but not drop a packet. That's the key. Spamming tree won't do that. Avaya data networking will. Test 1, 2. We still have the call up. One thing I will show you while we have this, while this is coming back, you can see that that's registered down now. But one thing that's very nice about this, I'll take RAP 4 for example. This is Avaya's data networking, what they call Unified Communication Management platform. It allows you to, with communication or configuration orchestration manager right here, it allows you to configure all your Avaya switches, routers, wireless, everything. Then with virtualization performance and fault manager, it allows you to monitor, gather statistics, alerts, tells you everything that's going on in the network. You can enter separate domains like I did here, so you can drill down to just monitor one particular section of the network, say you have remote offices, so forth. It gives you a lot of flexibility. Here's the thing I like the best. This is Enterprise Device Manager, which comes with the switch. It's with the code on the switch. So if you HTTP to the switch, you get this automatically. But if you have Communication Orchestration Manager or VPFM and you run it under a unified platform, I log in one time and I can launch any of the plug-in applications. And I can track what I did versus what somebody else does. So if I'm in here, we'll just close this out. And I'm in here, and I'm on VPFM, and I want to manage that switch, I just right-click on it, go to Tools, and launch EDM. And it's that quick. And I'm up and running. It's a very nice platform, very easy to manage. It works with voice. It'll monitor your PBX. Everything. Avaya is, they've thought a lot about this, and they've come a long way on the management software. So now we can see that this has come back in. We're green. Everything's good. We should see all our links back up. So let's go back over and see if we see, yep, he's back. Everything's green. He's back. We will check on VPFM. He's clean. Everything's running clean. So what did we just do? We've had multiple failures. We've had a core, we've had CPUs go down, we've had GPIXs go bad, we've had fiber cuts go bad, we've upgraded the switch in the middle of the day check 1212. We haven't lost a call yet. Just to tell you, just to show you that these switches are the ones that I've actually been dealing with. I'm going to go to the same switch stacks we've been going to. This phone right here is on switch port 1, so what I'm going to do is I'm going to go into that, and I'm actually going to go into the PoE and kill the PoE admin, and you will see this phone die. Alright, I'm going to go to the production, go to port 38, which this phone should be on. I'm going to go in and turn PoE off on that. Apply, and there you go. So, to prove it, I don't know any other way to prove that. I know this is a video and a lot of people do tricks, but I welcome anybody to come into our lab in Ensource. Let me give you my number. It's 904-821-3170. Give me a call. Come in. There's a lot more that we can show you. Automatic configuration. We even have a Cisco switch as an edge switch running link aggregation control protocol from here, which is a standard, back to a split MLT on the cores so that we can provide this functionality to a Cisco edge switch. The Cisco's not doing it. The secret sauce is in the Avaya. The Avaya is doing it all. But I welcome anybody to come in. I'll be more than happy to sit down, run through the lab, show you everything we just saw here and much, much, much more. All right? This is Frawley. I thank you for your time.